We're going to do some graphing. You probably thought, oh, I never have to graph ever again. I'm so sorry. We're going to do a little bit of graphing here in class. We learned last year how to do it on our calculator, so hopefully you remember that. The calculator does slope-intercept form. It does not do point slope form, so I do want to point that out to you. You may have to do some moving around and rearrange letter B in slope-intercept form, but I'll get to that eventually. Let's start with letter A. This is in slope-intercept form, so we can see that our slope is going to be 3 over 2 or negative 3 over negative 2. I like writing when it's applicable. Most of the time it's applicable. I can write my slope in two different forms. Positive 3 over positive 2 is the same thing as negative 3 over negative 2, because I know that a negative divided by a negative is a positive. So that's why I can write it like that. And it's going to cross through 3. So as we graph this, you want to create your coordinate plane. And the very first thing you're going to graph is positive 3. Here it is. And then you're going to use rise over run. So because it's a positive slope, this line should end up leaning to the right. If it doesn't, oops, something happened. You did something wrong. So let's go up 3. 1, 2, 3. Let's go right 2. 1, 2, and mark it. Okay, and you can do that a couple of times if you want to. Up 3. 1, 2, 3. Right 2. Okay, good job. Or you could go down 3. 1, 2, 3, left 2, 1, 2. As you can see, it's clearly a straight line, and my trick is don't look at your pencil tip, look where you're trying to go when you draw your line. Just look at your destination, not where you are right at that second. Don't look at the pencil tip because you end up getting offline if you do that. Okay? And you can verify this in your calculator. Press y equals, punch in 1.5x plus 3 or 3 divided by 2 times x plus 3 and hit graph, and it'll graph it for you. You may have to adjust your window if you're not seeing it right. So I'm just trying to bring some of these things back to you again. Okay? Now let's look at letter B. This is not something this is not a form you can put in your calculator under y equals. It should be slope-intercept form. You can easily rearrange this, and to do that you would want to first distribute, okay? So that'll give me negative 2x plus 2, and then take away 3 from each side. And now it's ready to throw into the calculator, okay? I have a negative slope, which means my line's going to lean to the left, and you can go ahead and practice that in your calculator now if you so desire, no big deal. I'm going to hand draw it two different ways. So let me start here. That'll be fine. Okay. So based on slope-intercept form, I need to start at negative 1. Now my slope is the integer negative 2. I can write that as negative 2 over positive 1 or positive 2 over negative 1. It matters not. They both equal negative 2. So if I go up 2, I have to go left 1. Up 2, left 1. Or I could go down 2, right 1. Okay? And so yeah, I have a negative slope. It should be leaning to the left, and did a good job. There it is. Okay? Now, you can actually graph out of point slope form. A lot of students are not comfortable with this because they have to remember that the original form is subtraction. So the number that's here, that positive 3, if you rewrote that as subtraction, it would be y minus a negative 3. There's your y1. y1 is negative 3. Your slope is still negative 2. That doesn't change. And then x minus 1, 1 is your x1. Positive 1 is. So the point that you would graph is 1, negative 3. So if we find 1, negative 3, 1, 2, there it is. There's 1, negative 3. That's from the equation, the original point-slope form equation. And then you're going to use the slope negative 2, and we don't have room to go down and right, so we're going to go up to left 1, up to left 1, up to left 1 in the same line. You can graph out of point-slope form. If you're worried about signs, you may not want to do that form. You may want to go ahead and convert it to slope-intercept form. But you can put it in your calculator too. Once you convert it to getting it to look like that, got to do slope-intercept form. All right, x equals 3. This is special. What's missing? What's missing? There's no y. Okay, that means if there's no y, it never crosses the y-axis. What kinds of lines never cross the y-axis? Okay, now let's think about it. Let's draw kind of a little sketch here. Here's the y-axis, here's the x-axis. So what lines are never going to cross that y-axis? Lines that are parallel to the y-axis, which are vertical lines. All right, let me switch colors here. All right, so this is going to end up being a vertical line. That's what this is. Okay, hard to remember, but that's what it is. So we're going to find positive 3, 1, 2, 3. There it is. And then our vertical line is going to run straight up and down through that. That's our line. X equals 3 is this line right there. It's a vertical line. If I had y equals 3, that would be a horizontal line. There's no x. It would never cross the x-axis. So it's got to be a line that's parallel to the x-axis, which are horizontal lines. Okay? So if you have questions about that, you're like, oh, I just forgot all about that. Well, let's practice that tomorrow. Thanks for listening. Nope, I didn't leave you any extra credit, so thank you for listening, and mark anything we need to talk about.